Chapter 8, Section 8. This is our last section for Chapter 8. And this is factoring by grouping. And so what this will allow us to do is to factor higher degree polynomials. So far, really, all that we've learned is quadratics, where we have a degree, like one of the variables is squared, and they've been trinomials. And now we're going to be looking at ones that are higher degree than just to second power and have more terms than just 3 with them. Okay, the first one, we're just going to kind of hop into it and show you some different ways of doing this. So the first one is 3n cubed minus 12n squared plus 2n minus 8. And one of the first things that you always want to do is look to see if they all have a greatest common factor. If there's anything that they have in common, if they all have an n or an x, or 2 can go into all of them, anything like that. That is not the case with this. There's nothing in 3n cubed, 12n squared, 2n, and 8 that is in common. And so what we're going to do is we're going to go straight to the way that we factored when it was in the form of ax squared plus bx plus c, and that was where we grouped them. Let's see if I can get my pen to work. Okay, got my pen working. Sorry about that. So we're going to group these, and we are going to find the GCF of each one. So for 3n cubed minus 12n squared, we're going to find what goes into all those. Okay, so I'm going to do this the long way the first time, but from now on, we're going to try to do a little bit more of this, where you just kind of can pick the GCF out. If you can't do that, if you can't pick it out just by eyeballing it, go ahead and feel free to do this. So we write each term separate, 3n cubed and 12n squared. So 3n squared, 3n cubed would be 3 times n times n, and 12n squared would be 2 times 2 times 3 times n times n. Let's try that again. Okay, and so what do they have in common? They both have a 3, they both have an n, and they both have another n. And so our GCF would be 3n squared. Okay, we do the same here with 2n and 8. Sorry, I'm writing with my mouse so that it actually works. 2n is already factored out. 8 could be 2 times 2 times 2. And so these have 2's in common. So now this part becomes 3n squared. And if we take 3n cubed divided by 3n squared, we are just left with an n. 12n squared divided by 3n squared becomes 4. Here we take a 2 out. 2n divided by 2 is just n, and negative 8 divided by 2 is negative 4. If all goes right, we're going to have the same binomials, which we can then rewrite n minus 4 times 3n squared plus 2. The 3n squared plus 2 comes from these remaining factors. And and therefore that is it factored out. Now, usually this would be written in front because it has a higher degree, but it's not a mandatory thing. Alright, let's try another one, but a little bit quicker. So we've got 8t to the third plus 14, so I'm going to block this off. There's the first one, there's the second one. The GCF of 8t cubed and 14t squared is going to be 2t squared. 8t cubed divided by 2t squared is 4t plus 7. Highest factor here is a 5. 20t divided by 5 is 4t. 35 divided by 5 is, you guessed it, 7. And so our final answer is 4t plus 7 and 2t squared plus 5. Sorry about that. It should be right there. A little bit nicer. Okay. Now, sometimes there is a GCF that you can pull out right away. With this one, again, there wasn't, and I should have pointed that out. But with this, there is. So what do these all have in common? Hopefully, the first thing you see is that they all have a Q in common. And the other thing they have is 4 can be divided into all of them. They all have factors. A 4 is a factor. And so 4Q is our GCF. And so we're going to rewrite this as Q cubed. This negative 8Q would become negative 2Q squared. This would become 3Q. And the last would become negative 6. Now, once we're at that point, what do? Are we factored all the way out? And now what we're going to go back to is just thinking about this part, and we're going to factor by grouping. So we're going to group first two terms together and the last two together, and we're going to factor that way. So the 4Q stays, but it's not going to affect us right now. These both have a Q squared, which means what's left is Q minus 2. These both have a 3 in common, which means we're left with Q minus 2 again. And you see this binomial inside is the same. So 4Q stays there. I'm going to write this part first, Q squared plus 3. And then the part that's the same, Q minus 2. And that is our factored polynomial. Here is kind of a step-by-step process of that. And so the first thing that you look for, get this in your notes, is factoring out the greatest common factor. Now, what I would suggest putting is if there is one. If there is one. There's not always a GCF that can be factored out right away. If that's the case, or whether or not there is, then if the polynomial has 2 or 3 terms, look for a difference of squares, a perfect square trinomial, or a pair of binomial factors. So what we're talking about is either look for a special case, that's what this is, or a pair of binomial factors. Do the chart, okay? Do the little chart where you say factors of A times C and then there's sums. And if that doesn't work, or if the polynomial has 4 or more terms, then we go to grouping, okay? And you should always check at the end that there are no common factors other than 1. So here's what we're talking about that. Do these have anything in common other than 1? Is there anything in here that they have in common other than 1? And the answer is no. Anything in here that 4t and 7 have in common, or 2t squared and 5 have in common, and that's not the case. Same here, same there. Okay, so again, the whole grouping thing is like an extension of things that we've done before. We just have polynomials that have 4 or more terms now.